Okay, good morning. We're moving nicely. We already covered 3.1, 3.2, and so there was exponential functions and an introduction to logs. We're going to move on to properties of logs today. So the first thing we need to remember are some properties of exponents. If you As you can see here, you have the product property, the quotient property, the power property, and I know you're already familiar with those from Algebra 2. So if you're multiplying exponents to values that have same base, different exponents, you can just add the exponents. If for the quotient property says that if you are dividing two bases with the same with different exponents, you can subtract the exponents, and then also finally the power property, you can multiply those two. All right, so now very similar properties apply for logs. As you can see here, I took this right out of the textbook. The product property says that for a log with base b of xy, that can be rewritten as log base b of x plus log base b of y. Quotient property says that log base b over x over y can be rewritten as log base b of x minus log base b of y. And the power property says that log base b of x to the p power can be rewritten as p times log base b of x. So I'm going to go over some examples and show you how we can apply these properties. For example, number one. There was happens. Okay. Oh, still getting used to this. I'm so sorry. Okay. So for 1a, it's asking you to express each logarithm in terms of log 5 and log 3. So what I would initially do would be find two numbers, two factors of 75 that are either a multiple of 5 and 3 or 5 and 3. So what I have here is I can rewrite, I know that 75 is 3 times 25, so I can rewrite this as log. And instead of writing 75, I can break that up to 3 times 25. And now I can change that multiplication sign to a plus sign, and then I have to write the word log twice. So I get log base 3 plus log 25. Now the thing is I cannot use 25, so I have to make sure that I rewrite 25 in terms of 5. I have a couple choices here. I can write log 5 times 5 and then write log 5 plus log 5. Or I can just write 25 as a power of 5. So I can do log base 3. Sorry, log base 10, it's a common log, plus plus log 5 squared. And then I can use the power rule and pull the 2 up front. That's the power rule. And my final answer would be log base 3. Sorry, I keep saying base 3. It's not base 3. Log 3. Let me erase that. Okay. All right. So log 3 plus 2 log 5. And that would be my final answer, because I was able to express each log in terms of 5 and 3. So that's what the answer looks like. Okay? For the second example, you have log 5.4. So what you need to do again is find either multiples of 5 and 3, that when you do a set of operations will result in 5.4. So what I did here was I rewrote that as log. I know that 5.4, 20, I know that 27 divided by 5 is 5.4, so I rewrote that as log 27 divided by 5. And that will give me my 5.4. The problem is 27, I need to rewrite in terms of 3. And I know that 3 cubed is 27. So I'm going to do that step first. And I am going to write 27 as 3 to the third power. So I have now log 3 to the third divided by 5. Let me fix that writing a little bit. Okay, so I have log 3 to the third divided by 5. And now I can expand that and write as log base, I keep saying base, log 3 to the third minus log 5. So now I have log 3 to the third minus log 5. And the last thing I can do is use the power property and pull that 3 in the exponent to the front of log 3. So I get 3 log 3 minus log 5. Yeah, this is getting pretty jammed here. Let me see if I can move up so you guys can see. That's better. Okay, minus log 5. So 3 log 3 minus log 5. And that would be my final answer. Okay. All right, so moving on. You also need to be able to simplify logs. So by simplifying logs, it means in this case, you will be able to get just a number. That will not always be the case, but let's manipulate some of these values here. And if you look at 2a, it's asking you to simplify that. So what I know when I look at this problem, I know that 36 can be written as 6 to the second power. Why is that important? Because I'm hoping that somehow I'm going to get a log base 6 of 6 to cancel out. So now I have log base 6 of cubic root of 6 squared. Now I am able to rewrite that cubic root as a rational exponent. So now I have log base 6 of 6 to the 2/3. And this is just what I was hoping for, because you learned in 3.2 that this go away, and my answer is simply 2/3. All right. For 2b, let's see what I can do over here. I know that natural log and natural base e are inverses. So what I see here is I can immediately make that go away. So I'm left with 9 plus, and once again I can just cross those out, and that is 5 times 3, which is gonna, when I evaluate that, 9 plus 12 is just 21. Okay. Now, another skill you will need to perform is expanding logs. So when you expand logs, you're essentially using all the properties of logs to make these longer. Okay, so any multiplication is going to be changed to addition, and you'll be using the word log more than once. So let's see what we could do here. You have log base 13 of 6a cubed bc to the fourth power. So I'm going to start with anything that is being multiplied there. I know that 6a to the cubed means 6 times a to the cube to the third power. Okay. So I can think of these as separate entities here. Okay, so instead of multiplying, I'm going to change that to addition, and I am going to write log base 13 for each one of them. So now I have log base 13 of 6. Now that multiplication is going to change to addition, but then I have to write the word log base 13 again. So plus log base 13 of a cubed, and then another multiplication, so plus log base 13 of b, and then finally plus log base 13 of c to the fourth. All right, now any exponent, I can use the power property and pull it up front. So let me see if I can write a little more neatly here. So now we have log base 13 of 6 plus, I'm going to pull that exponent up front. So it's going to be 3 3 log base 13 of a plus log base 13 of b plus 4 log base 13 of c. And that is going to be the answer. Log base 13 of 6 plus 3 log base 13 of a plus log base 13 of b plus 4 log base 13 of c. Okay. Let's take a look at the next problem, which is right here, 3b. So for 3b, we have natural log 3y plus 2 over 4 cubic root of y. So the first thing I will do in this case is change the division sign to subtraction and write natural log twice. So in this case, I would get natural log 3y plus 2 minus natural log 4 times cubic root of y. Now looking at this expression, I see that 4 cubic root of y means 4 times cubic root of y, which means I can expand that. So I am going to rewrite that as natural log. Now this one I cannot touch because it's a plus. I can only change multiplication to addition. This one I have to leave alone. So natural log 3y plus 2, and then minus, I will rewrite natural log 4 plus natural log cubic root of y. Now, because I have a negative in front of this binomial, I need to distribute the negative. So I have natural log 3y plus 2 minus natural log 4, and then minus natural log cubic root of y. I'm moving along nicely here. So now what else can I do? Well, I can rewrite this as a rational exponent. So I'm left with natural log 3y plus 2 minus natural log 4. And I'm going to write that as an exponent first. So minus natural log, you should know that cubic root of y could be rewritten as y to the 1/3 power. And then I can pull that up front. And that should be my last step. So now my final answer is going to be natural log 3y plus 2 minus natural log 4 minus 1/3 natural log y. Final answer. Okay? All right. So now, what else do we have here? Example number 4. So this condensing logs is essentially what we just did. You just have to go backwards. Instead of making it longer, you're going to make it shorter. So when you condense, you should bring the expression down to the word log or natural log appearing only once. Okay? So let's see how we can approach this one for A. So for A, we have -5 log base 2 of x plus 1 plus 3 log base 2 of 6x. So right away, when I look at this, I think, well, that can be changed to an exponent. This can be changed to an exponent. So I'm going to perform that first. And I'm going to say that log base 2 of x plus 1 to the -5 power plus log base 2 of the quantity 6x to the 3rd power is my first step. So I also see that there's a plus here and the word log twice. So I'm going to condense that. And I am going to say that I can write log base 2 only once. And write x plus 1 to the -5th power. Instead of the plus, now it's going to be times 6x to the 3rd power. Now remember, because the quantity 6x is in between parentheses, you should raise the 6 to the 3rd power and the x to the 3rd power. So now what I have is log, let me move this over here. Okay. I have log base 2 of x plus 1 to the -5th power. And then the quantity 6x to the 3rd power should be rewritten as 6 cubed, which is to 16, x to the 3rd. So now what I can do is just, instead of having my negative exponent, I can write this in the denominator. Remember, every time you have a negative exponent, you should move that to the numerator or denominator, depending on what it is. So my final answer now can be written as log base 2, and 216x cubed is going to be in the numerator because it's a positive power. And x plus 1 to the -5th power is going to be in the denominator and be written as x plus 1 to the 5th power. And that should be final answer. Okay. All right. So that was for A. We need to do for B. We have it here. Yes. Okay, so this one we are going to condense as well. So to condense this very long expression, once again, we want to bring it down to single ln only once. So This minus here is going to change to division. This is going to change to division. And that's going to become an exponent. And the more we do this, the fewer steps we probably will need to take. So I can rewrite this as natural log, the quantity 3x plus 5. And those are going to be in my denominator. So I can make that for an exponent for x. So x to the fourth and x plus 1. Sorry, x minus 1. Done. Okay, I know I didn't spend a lot of time on this one, but hopefully with more practice we can be more efficient. Now we need to go to 5a. I think. Oh, okay, and 5a requires you to apply the change of base formula. And what the change of base formula does is it allows you to evaluate logs with different bases, not just common log, which the base is 10, or natural log. Those two, you can just input the value in the calculator. But if you have different bases, most likely you'll be required to use the change of base formula. And this is, of course, when you're not able to evaluate logs without a calculator. So what it says is this: for any number, log base b of x can be rewritten as log base a of x, and this a here can be either your common log or your natural log, okay? You can use either one on the calculator. Of x divided by log base a of b. I think it's going to be easier when we look at some examples. Oops. With numbers. All right. So when you look at 5a, naturally, it's not possible to evaluate this without a calculator. So what you should know is that you can rewrite this as log, and I'm going to use a common log, okay? 40 to 12 is always the big number over log of the base, which is 78. Okay? It's always the bigger or the higher number over the log of the smaller number of your base. So at this point, you just enter it on the calculator and just make sure that when you enter this on the calculator, you close parentheses. So you should input log, and the calculator is going to open parentheses for you. So it should be 4212. Close parentheses, that's the important part. Then you do divided by log, and then once again the calculator is going to open parentheses, 78. And this doesn't matter if you close or not, but get in a good habit and close parentheses. And when you input that on the calculator, what you should get is 1. When you put that on the calculator, your answer should be 1.916. And that's rounded to the nearest thousand. All right. Okay, for get rid of this. Let me put my parentheses back, select 2, and here we go. All right, for 5b, change of base again. You can use natural log if you want, or common log. I am going to say that this can be evaluated as log 33 divided by log 15 on the calculator. Put in log 33, close parenthesis, divided by log 15. And when you do that, you are going to see, I keep forgetting to hit on it twice. Okay. So when you input that, you should get 1.291. Okay. All right. And then the third one, you can apply the same process, just use the fraction, that's fine. So here we have log base 10, log 10, which is just going to be 1 divided by log 1/3. And when you do that, you get negative 2.096. Okay. See if there is. I think that's it. Yeah. All right. So that covers 3.2. I will be assigning some problems, and if you have questions, you can reach out to me on Google Classroom. As always, you can post comments, you can email me. If you want, we can set up a Google Hangout, and we'll be happy to answer any questions. See you next time.